All right, in 4.4, we're going to take a look at solving exponential and logarithmic equations. In the first part, we'll just do exponentials. So we're just going to go through a few different scenarios and a few different strategies for solving different types of exponential equations. The first situation that we're going to look at is when both bases are the same. Now, obviously, right here, these are not the same base, but I can write them with the same base. Both 25 and 125 are powers of 5. So for situations like this, we need to be able to recognize those types of things. All right. Now, I can rewrite 25 as 5 squared. So that'll be 5 squared to the x power. And I can rewrite 125 as 5 to the third power. Now, if I have a power to a power, I just multiply them. So this would just be 5 to the 2x equals 5 to the third. Whenever I have a situation like this, when I have the exact same base, I can just set the exponents equal to each other. And then all I would have to do is divide by 2, and we'll get that x is 3 over 2. Now notice this only works if we just have one exponential equal to one exponential. If I had some other term, like being added or subtracted, this wouldn't work. Okay, this only works if we have one exponential equal to another exponential with the same base. Okay, so let's try another example like that. All right, here I've got 3 to the x plus 1 equals 9 to the x. Well, here I can rewrite both of these with a base of 3, so this one would stay the same. This one would become 3 squared to the x power, right, which would just be 3 to the 2x. And then once I have the same base, all I need to do is set the exponents equal. So I'll have x plus 1 equals 2x, subtract the x over, and we'll get that x would be equal to 1. All right. So let's take a look at our next situation, right, where we have an exponential just equal to a number. Okay? This is probably the most common form that we're going to look at. This is what's probably going to show up most in application problems. Right? So whenever we have an exponential equal to a number, we can just rewrite this as a log to get the exponent down. Okay, so we talked about this in the first section. To rewrite an exponential as a log, the base of the exponential will become the base of the log. So this will be log base 3 of 10 equals x plus 1. Okay, now I can plug this into the calculator then. First we could solve for x. Let's do that. So let's subtract 1 over. So we'll have log base 3 of 10 minus 1 equals x. Now make sure that we understand that that minus 1 is on the outside of the log. Okay, this would not be the same thing as log base 3 of 9. I'm not subtracting this 1 on the inside. That is on the outside of the log. So we can put that into the calculator. And remember, if you go to math, log base, you can put in log base 3 of 10 minus 1, and we'll get 1.096. Okay, generally we go to 3 decimal places. So 1.096 is my answer. Now I do want to show you what's actually happening here, the math behind this, okay, why this works. So what we're actually doing to undo this exponential, I'm really taking the log base 3 of both sides of the equation. Okay, so I'm taking my exponential and just taking the log base 3 of both sides. Now, if I use my power rule here, I can bring this x plus 1 out front. And I can rewrite this as x plus 1 times log base 3 of 3. Now, log base 3 of 3, this is saying 3 to what power equals 3? That would just be 1. So this whole thing, log base 3 of 3 is equal to 1. And we just get x plus 1 equals log base 3 of 10. Okay? And then that's where we ended up starting this problem, right? We would just solve from there for x. Okay? But this is the math behind why this works. Okay? Rewriting this as a logarithm. All right? So let's take a look at another example like that. In this situation, we first need to get the exponential by itself. In order to use the strategy that we did on the last problem, the first thing I'm going to do is add 2 to both sides. Then I'm going to divide by 3. This 3 is not part of the exponential expression. This is just being multiplied. So if I divide both sides by 3, I have e to the 2x minus 1 equals 5. Now I can rewrite this as a logarithm. Right? So to do that, we're going to do log base e of 5 equals 2x minus 1. Log base e is the natural log, so that'll just be natural log of 5 equals 2x minus 1. To solve for x, we'll add 1 over, and then divide by 2. So we'll have natural log of 5 plus 1 over 2 equals x. And then that I can plug into my calculator. So natural log of 5, what was it? Natural log of 5 plus 1 over 2 gets me 1.305 if we go to 3 decimal places. Okay? So in our next scenario, we have 2 exponential expressions on either side of the equation. Right? In these, I cannot rewrite the bases to be the same like I did in the first 2 examples. Whenever we have a situation like this, what we are going to do is just take the natural log of both sides. If I take the log base 4 of both sides, that would get this exponent down, but that would not get this one, right? That wouldn't cancel this one out, right? Whenever we have different bases that cannot be written the same, I'm just going to take the natural log of both sides. So I'm going to have the natural log of 4 to the x plus 1 equals the natural log of 3 to the 2x. Now, once we do this, I can use my power rule to bring my exponents out front. So I'll have x plus 1 times the natural log of 4 equals 2x times the natural log of 3. If there is any distribution, we want to do that. And we do have distribution here on the left side. I'm going to distribute natural log of 4 to x and to 1. So that would become x times the natural log of 4 plus 1 times the natural log of 4, which would just be natural log of 4, equals 2x times the natural log of 3. So now I want to get x by itself. I have multiple expressions that have an x. We've solved problems like this before. What we need to do is get every term that has an x on one side of the equation and everything else on the other side. The easiest way to do that in this situation would probably be to subtract this term over. So I'm going to have natural log of 4 equals 2x times the natural log of 3 minus x times the natural log of 4. Once I do that, I can now factor an x out of every term on the right side here. So I will have natural log of 4 equals x times 2 natural log of 3 minus natural log of 4. Then, to get x by itself, I can just divide both sides by this. And we will end up with natural log of 4 over 2 natural log of 3 minus natural log of 4. And this, then, I can put into the calculator. So natural log of 4 over, what is it, 2 natural log of 3 minus natural log of 4. So 1.710 if we go to 3 decimal places. Okay, let's try one more of those because these ones are a little bit longer, maybe a little bit trickier. Okay, so 3 to the 2x plus 5 equals 17 to the x. I just want to take the natural log of both sides. Oops. And the reason that we do that is now we can use the power rule and bring the exponents down. So I'll have 2x plus 5 times natural log of 3 equals x times the natural log of 17. Distribute over here. So 2x times the natural log of 3 plus 5 times the natural log of 3 equals x times the natural log of 17. Get the x's on one side, so I'm going to subtract this one over. So we'll have 5 natural log of 3 equals x natural log of 17 minus 2x natural log of 3. Factor an x out on the right side. And divide. So we'll end up with 5 natural log of 3 over natural log of 17 minus 2 natural log of 3. Now, I should point out that this would work with a log of any base, okay? I could take the common log of both sides. I could do log base 10. I could do log base 43, right? I could do log base a million. It does not matter what the base of the log is as long as I take the same base on both sides of the equation. So let's plug this into the calculator. So 5 natural log of 3 over natural log of 17 minus 2 natural log of 3. And we get 8.637. Okay. Let's take a look at a couple more. All right. Now, in this situation, all I would need to do is multiply both sides by the denominator. All right. So if I multiply both sides by 2 plus 3 to the x times 2 plus 3 to the x, those factors are going to cancel out over here, and we'll just be left with 4 equals 1 times this. So that would just be 2 plus 3 to the x. Now, we're just solving like we did in the first few problems. I want to get the exponential by itself. So I would subtract the 2 over. We'll get 2 equals 3 to the x. And now I can rewrite this as a log. Right? So I'm going to have log base 3 of 2 equals the exponent. Right? And again, we can think about that as a lazy 7. Right? Log base 3 of 2 equals x. We can plug log base 3 of 2 into the calculator. By doing math, log base 3 of 2 is 0.631. All right. And remember, what this actually means is 3 to the 0.631 power equals 2. Okay, so let's do one more example like that. Okay, this one looks pretty similar. So here, start by doing the same thing, multiply both sides by the denominator. So we'll end up with 5 equals 4 times 2 plus 3 to the x. Distribute my 4 through, 5 equals 8 plus 4 times 3 to the x. Now note, this is not the same as 12 to the x. Okay, I cannot multiply this 4 times the base because we have an exponent. Okay, so please do not try to do something like that. But now we want to solve for the exponential. So I'm going to subtract the 8 over. We'll get negative 3 equals 4 times 3 to the x. Divide both sides by 4. We'll get negative 3/4 equals 3 to the x. And now I can rewrite this as a log. So we'll say log base 3 of negative 3/4 equals x. But we have a negative value on the inside of a log. If you remember, back a couple of sections, we said that the domain of a log is only 0 to infinity. We can only have positive values inside of a log. Since I ended up with a negative value inside of a log, that means that this problem has no solutions. All right. One final example to take a look at here. Let's take a look at a story problem. Here it says the amount of a certain drug left in the bloodstream in milligrams per milliliter T hours after it was administered is given by this formula. We want to figure out how long it's going to take for the amount of this drug in the bloodstream to decrease to 1 milligram per milliliter. So I am just going to say this amount in this situation is equal to 1. So 1 equals 4 times e to the negative 0.1204 t power. And then I just want to solve this equation for t. So the first thing I would want to do is get the exponential portion by itself. So I'm going to divide the 4 over. So I'll have 1/4 equals e to this power. Well, now I can rewrite this as a log, or again, we can think about that as taking the natural log of both sides. So I'll end up with the natural log of 1/4 equals negative 0.1204 t. All right. Then divide both sides by negative 0.1204. So if we take natural log of 1/4, is just 0.25 over negative negative 0.1204. We get 11.514. So in this case, that was in hours, right? So the answer would be after about 11.5 hours, the amount of this drug in the bloodstream would decrease to 1 milligram per milliliter. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.